crates of mass 10 kilograms and 50 kilograms respectively are connected with a rope of negligible mass and are resting on a horizontal floor, as shown. A force 500 newtons is applied parallel to the surface and the two crates accelerate to the right. The total frictional force experienced by the two crates has a magnitude of 400 newtons. 1/4 of this frictional force acts on the 10 kilogram crate and 3/4 on the 50 kilograms crate. Calculate the normal force exerted on the 50 kilogram crate, magnitude of the acceleration of the crates, magnitude of the tension in the rope. What would happen if the rope suddenly breaks? Solution. Before we proceed, let us identify the situation. The surface is horizontal. It is a rough surface. The two crates comprise of a system that is in non-equilibrium state since they are accelerating. In this problem, we shall consider the two crates as a system, the 50 kilograms crate as one body and the 10 kilogram crate as the other. Let us find the forces acting on the 50 kilogram crate and the 10 kilogram crate and draw their free body diagrams. Let us call the 50 kilograms crate as crate 1 and the 10 kilogram crate as crate 2. For crate 1, the force of gravity Fg1 is acting in the downward direction. The normal force acts perpendicular to the surface. The plane of motion is along the horizontal surface, so the net force in a direction perpendicular to the plane is 0. A force F applied is applied on the 50 kilogram crate towards the right. A frictional force acts in the opposite direction. There is also the tension in the rope. That completes our free body diagram for the 50 kilogram crate. Let us now consider the 10 kilogram crate, which is the second body. The force of gravity Fg2 is acting in the downward direction. The normal force acts perpendicular to the surface. The plane of motion is along the horizontal surface, so the net force in a direction perpendicular to the plane is 0. For the 10 kilogram crate, the tension in the rope T is acting towards the right. There is a frictional force F2 acting towards the left. That completes our free body diagram for the 10 kilogram crate. For the 50 kilogram crate, let us consider the force perpendicular to the plane of motion. Vector Fr1y equals vector Fg1 plus vector N1 equals 0, as the forces are balanced. Taking the upward direction as positive, we get negative m1g plus n1 equals 0. Vector n1 equals m1g equals 50 times 9,8 equals 490 newtons. Therefore, vector n1 is 490 newtons in the upward direction. We can apply Newton's second law to the motion of the 50 kilogram crate. Vector Fr1x equals m1 vector ax. Vector Fr1x is the vector sum of the forces on the 50 kilogram crate along the horizontal plane. Therefore, vector Fr1x equals vector F applied plus vector F1 plus vector t. Taking the direction towards the right as positive, we get vector Fr1x equals F applied minus F1 minus t. Combining 1 and 2, we get m1 vector ax equals F applied minus F1 minus t. Substituting the values, we get 50 times a equals 500 minus 3/4 times 400 minus t. We can also apply Newton's second law to the motion of the 10 kilogram crate, the second body. Vector Fr2x equals m2 vector ax. Vector Fr2x is the sum of the forces on the 10 kilogram crate along the horizontal plane. Therefore, vector Fr2x equals vector t plus vector F2. Taking the direction towards the right as positive, we get vector Fr2x equals t minus F2. Combining 4 and 5, we get m2 vector ax equals t minus F2. Substituting the values, we get 10 times A equals T minus 1 over 4 times 400. We solve the two equations 3 and 6 simultaneously. 50A equals 500 minus 300 minus T. 10A equals T minus 100. Adding the equations, 60A equals 100. Therefore, A equals 1,67 meters per second squared. This is the acceleration of each of the crates to the right. The tension in the rope can be found using equation 6. 10 times 1,67 equals T minus 100.
Therefore, T equals 116,7 newtons.
What would happen if the rope suddenly breaks? As we can see, the 50-kilogram crate continues to accelerate to the right, whilst the 10-kilogram crate has an unbalanced frictional force acting on it during its motion and therefore comes to rest. The velocity of the 10-kilogram crate decreases and finally comes to 0.
Starting to feel it? Now go master it with Maski.